Okay, so I'm going to talk about measure today, angle measure. So there are two types of measures for angle. One is called the degree measure, and the other one is called the radian measure. So I'm going to start with the angle measures now. An angle is so if I have this point here, if I draw a two vertex from this point, so call this ray 1. So this is a ray 1, and this is a point A, and this is a point O, and this point I'm going to call it vertex. And then I draw another ray from this vertex. So I'm going to call this ray 2. Let's call this point. So the ray 1 is going to be called initial side. Ray 2 is going to be called terminal side. So when we go from ray 1 to ray 2, then we form this angle here. So we form this angle here, and that's called a positive angle. So if it's counterclockwise direction, we call this a positive angle. Clockwise. That's the direction of it. So we often interpret an angle as a rotation of the ray 1 onto ray 2. So if ray 1 is onto ray 2, then we form an angle. We can have another scenario where, okay, this is again a vertex, so this is ray 1, so let me call this R1, ray 1, and that's initial side. And then if I put the ray 2 here, so then ray 1 will be onto ray 2 in this direction, and this is called the terminal side. And we will call this a negative angle. Which is clockwise. So clockwise angles are going to be negative, and counterclockwise angles are going to be positive. So this is clockwise. Okay. All right. So the measure of an angle is basically the amount of rotation about the vertex required to move ray 1 onto ray 2. So intuitively, this is how much the angle opens. One unit of measurements of angle is the degree. So I will write it this way. So an angle of measure 1 degree is formed by rotating the initial side by 1/60 of a complete revolution. So in calculus and other branches of mathematics, a more natural method of measuring angle is used, and this is the radian measure. So let's talk about that now. So radian measure. So if a circle of radius 1 is drawn with the vertex of an angle at the center of the circle, then the measure of this angle in radian is the length of the arc that subtends the angle, which is the following. So what I'm saying is really just this. Okay, so this is angle at the center. So you can think of like this 2 ray, and this are 1 because it's a unit circle, so the radius is 1. So this angle, the angle that subtends the arc, this is the arc that it subtends. Okay, and that's the radian measure of theta. So radian measure of theta. So if a circle of radius 1 is drawn as this picture with the vertex This is the vertex at the center. Then the measure of this angle in radians, we will abbreviate this, so we will call it rad like that, is the length of the arc that subtends the angle. So to form this arc here, so I'm going to need this angle. So basically, the length of the arc is going to be the measure of the angle that subtends the arc. Okay. So the circumference of a circle of radius 1, okay, so if you have a circle like this, and then this is the radius 1, let's say, this is radius 1, and we will call this, so we will call this 1 radian, and if, so for instance, if we have another circle here, so if we have, let's say, a circle, okay, this is a line that goes through the center of the circle, then starting from this point, going to the other end, it's called a pi radian. So basically, half of the circumference here is pi radian, and the circumference of the circle is 2 pi r. If the radius is 1, so that's really just 2 pi, which is the length of. So if you started from here, it's going to be the distance that you travel on the circle. So that's also called one revolution, if this is a circle with radius 1. And therefore, the half of it will just be pi, so you will just divide the circumference by 2. So a complete revolution has a measure 2 pi radian. So let me write that here. So one complete revolution is equal to 2 pi. Or in a unit circle, I mean, in general, this will be 2 pi. The circumference is 2 pi r, so radius is 1, so this is therefore 2 pi. And let's look at different scenarios here. So let's say I take half of it. So let's say here's another circle. Okay, so let's say I take this to the center of it. I take this, so that's the right angle here. So then the measure of this arc here is going to be 90 degree as well, or you can say pi over 2 radian. Okay, so this is pi over 2 radian, and so on. So this, let me just give you one more. So let's say I take this circle here, and then I drove. Goes through the center. This goes through the center here. So going from here to here is pi over 2 radian. And if you go half of it, that's going to be pi radian. So that means this is also pi over 2. So then the one half of it is pi radian. And if you go here, that's another pi over 2. And if you go here, that's another pi over 2. So basically, if I want to go from this point, let's see, if I want to go from this starting point all the way to here, that will be 3 pi over 2, because you got 1, 2, 3. So all the way here is 3 pi over 2. All right. So now we have, so we define two measure for angle, right? So measure two measures, right? We have angle, we have a degree measure, and then we have a radian measure. And you can always go from one to another. So I can convert degree to radian or radian to degree. So that can always be done. Now in the previous picture, so what we established that, okay, if you do half of the circle, right, that's pi radian, right? And pi radian is equivalent to 180 degrees. So then I can now easily find what is 1 radian or what is 1 degree. So if I divide both sides by pi, then 1 radian is just going to equal to 180 over pi. Or if I divide both sides in this form, if I divide both sides by 180, then I have pi over 180 equal to 1 degree. So these two things will help us to do the conversion. So now if I'm converting degree to radian, then I will just simply multiply by, if I'm converting degree to radian, then I will simply just multiply by pi over 180. Because I know that 1 degree is pi over 180, so then I'll just multiply the given degree by pi over 180. Okay. Now the next, if I want to convert radian to degree, then I'll just do the reciprocal of this. So radian to degree means I multiply by 180 over pi. So let me give you a few examples. So let's say, we want to convert, so convert to radian. So this says that if you want to convert degree to radian, you're just going to multiply by pi over 80. So it's going to be 60 degree multiplied by pi over 1 degree. So 60, this is like 60 over 1. So you can just multiply the numerators, multiply the denominator, and simplify your answer. So if I simplify this, so I divide top by 60, that's just going to be 1. So 1 pi. Divide the bottom by 60, I get 3. So then it's over 3 radian. So 60 degree is equal to pi over 3 radian. So what this looks like on the circle, let me show you that. So this is what it's going to look like. So this is the center of the circle. This is the center of the circle. So you just go 60 degree. So you subtend 60. Okay, and that's going to equal to this. So 60 degree will be something like this, right? Or you can just write, say, the measure of this arc. So if this is OAB, so I can write it like this. I can say AOB, the measure of this arc equals 60 degrees. It's not the length of the arc, though, just the measure of the arc. We're going to come to the length of the arc. That will be a different topic, but just the measure of the angle is 60 degrees. Okay. Now next, let's look at this example. Let's say we want to convert 3 pi over radian to degree. So to convert radian to degree, I'm going to multiply by 180 over pi. So I take the given radian measure and multiply this by 180 over pi. And then I can just now simplify this. So you see pi will cancel each other. So you'll have 1 here. So multiply the numerator. So it's 3 times 180 divided by 2 times 1, which now I can just simplify this. This is 90. 3 times 90 is 270 degrees. So 3 pi over 2 is equal to 270 degrees. And let me also tell you the location of this angle. Okay, so that's going to look like this. So let's say this is the center again. This is the center. We started from here, so you can consider this to be your initial point, and then you go all the way to C. If I divide this like this, right? So if I go all the way to this point, that's 90 degrees because this is a right angle here. So that's pi over 2. If I go all the way to this point, that's pi. If I go all the way to this point, that's 3 pi over 2. And if I come back to the same point, that's 2 pi. So therefore, 3 pi over 2 is going to be the measure of this arc right here. So that is is 270 degree, or you can say 3 pi over 2 radian. Okay. So as you see, it's very easy to convert. So, and we can work with any type of measure, so depending on the situation, right? Depending on the problem. Okay. Now, next we'll talk about angles in standard position. So angles in standard. Okay, so an angle is in a standard position if it's drawing in the XY plane with its vertex at the origin and its initial side on the positive x-axis. So here are some illustrations. So if I just draw this line here. Okay, so you have the vertex at the center. So the vertex is right here. So an angle is in a standard position if it's drawing in the XY plane. So this is XY plane with its vertex at the origin. So this is the vertex. And the initial side is on the positive x-axis. So this will be one example. And then this is an angle in standard position. So let's call this angle theta. So basically you have an angle, the vertex is at the origin and the initial side is on the positive x-axis. Okay, so that's one type of illustration. So let me just give you another type. So let's say we have this. So I could put vertex right here, and then this is the initial. So this is like a terminal side. So this is the angle in standard position. So this is theta. So we'll call this angle in the first quadrant. Here we'll call the angle in second quadrant. And then another case is this. So you can have an angle right here, which is this angle here. And that's called angle in third quadrant. Angle in third quadrant. Now one more case. You can also have a vertex here and angle right here. So then this is the angle in standard position. So this is called angle in the fourth quadrant. So these are all the cases you will see. So, I mean, you can do this in many other directions as well. But it has to be, okay, if you want to call an angle in standard position, it has to be drawn in XY plane with the vertex at the origin and the initial side on the positive x-axis. Okay, so if I just want to do like, give you some example that are in standard position. So that will be like, let me just give you an example. Let's say I want to draw 315 degree. Draw this angle, which is going to be y plane. Okay. So you can just do this. So started from here. So this is 90 degree. This is 180. This is 270. And 315 is going to be somewhere here, right? So you're going to end it somewhere here. Then you just draw your terminal side where this point is. So 315 degree. Okay, so 315 degree, therefore it's in the fourth quadrant. And then let's take an example. So let's say I want to draw 240 degree. 240 degree is bigger than 180 and it's less than 270. So you can say this is 270 up to here, it's 90 up to here, 180 up to here, and 360 up to here. So I'm going to go like this. See, this is 90, this is 180, and then 240 is going to be between 180 and 270. So it's going to be somewhere right here. And I just draw my terminal side here. Quadrant 3. Okay, so these are how, okay, let me just also negative angle. So let's say negative 135 degree. So how we draw this? So this time, okay, so this is 0, right? So this is like 0 degree, this is 90 degree, and this is 180 degree, and this is 270, and this is 360 degree. If you go positive, then this is the positive direction. This is positive, and this is negative direction. Remember, negative angles are in the clockwise direction. So then if I go like this, so this will also be negative 90 degree, right? Because if I go like that, that's negative 90. And then if I go a little bit this way, right? So then this is where the negative 135 is. So this will be negative 135 degree. So if I go right here, this is negative. If I continue like this cycle, so this is going to be negative 270, and this will be also negative 360 if I go negative direction. Okay, maybe one more example with the negative angle. So another example of negative 330 degree. So that will be, so this is 0, this is negative 90, this is negative 180, this is negative 270, and this is negative 360. Okay, this is negative 90, negative 180, negative 270, and then negative 330 is going to be somewhere here. So then you draw your angle like that. So in the next lecture, we can discuss about the equivalent angles, which are called the coterminal angles. So we can talk about this, and this drawing is going to be very useful there.